Hello, this says simplify fully, and it's 5 minus root 7 and 5 plus root 7. So that gives us, I wouldn't always do this, but 25, and it would be minus 5 root 7 and plus 5 root 7, which actually cancel, and then root 7 times minus root 7 equals minus 7, so that's on the top you're going to get 25 minus 7 over root 2, which equals 18 over root 2. Now we're just going to have to times by root 2 on the top and the bottom. Then on the bottom we get 2, and on the top we get 18 root 2. And so that means we get 9 root 2. So it's quite sort of straightforward, but I hate it when people say that, but we're going to say that anyway. Right, AB equals AC. So this from here to here is the same as from here to here. Okay. D is the point such that AD to DB is 1 to 2. So this and this, I'm assuming, are the same. And then that bit and that bit are the same. Okay, prove that DBC is congruent to triangle EBC. EBC, oh, so this bit here and this bit here are the same. So how would we do this? So we know that this one and this one are the same. So that means, what does that mean? That means that these two are the same. And these two are the same, right? Which means that we know that this one, at this stage we're starting to get into sort of tricky quarters, and this one are the same. And if those two are the same, then we know that these two are the same, and these two are the same. I think you'd actually have to write all this down. Just can't be bothered because I'm not doing a GCSE. I am in some ways, and that would make these two the same. I don't think you can do what I'm doing, by the way. I'm getting a little bit carried away. Anyway, basically that's why they're congruent, because if you've got the same, if you've got angle, 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 that equals angle, 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 therefore same or congruent triangles. Like you can't have something that has all three angles the same without it being a congruent triangle. Right, that was quite poorly explained, I apologise. The diagram shows a solid cylinder. The height of the cylinder is 14 centimetres and the radius is r. The volume of the cylinder is 126 pi centimetres cubed. Work out the exact total surface area of a solid cylinder and give your answer as a multiple of pi. So that means we've got to find r. So to find r, we'll divide through by 14, and that is 9. So that means that 9 pi is the area of the circle, equals area of circle. So that means that r equals 3. Which means that D equals 6. Now, in order to find the surface area, we have to do the area of this of 2 circles. So area of each circle equals 3 squared pi. And that equals 9 pi, which we knew already, and then times by 2 equals 18 pi for top plus bottom. Now, in order to find, now we know what D is, so D is 6, and so the circumference of that is 6 pi. So circ equals 6 pi. Therefore, the surface area of that kind of rectangle, if we opened up that the Coke can, as it were, we'd get 14 times 6 pi. 14 times 6 is 60, it's 84 pi. So surface area of middle bit of, yeah, that'll do, equals 84 pi. And then we add them together. So whole SA equals 18 pi plus 84 pi equals, put a pi there, 2, 1 up, 102 pi. Okay, so a triangle has vertices A minus 7. I don't think I'm going to love this, so let's just do this. So minus 7, that's about, say, there, minus 7, 1. That's A. Not loving it. B, 2, 0. That's B. Put that in, B. So let's go 2, 0. Let's put this in as minus 7, 1. I haven't even looked at what the answer is yet. Oh, or the question. And C is 0 minus 6. So that's there. That's C. 0 minus 6. There we go. That's our little, it's not perfect, but that'll do. It's our triangle. Oh no, that's not good. That's our triangle. Right, there we go. Find the equation of the line that passes through A and is perpendicular to BC. Oh, so I'm finding that one there. It's going to be negative, isn't it? So BC is BC. So let's find A, the gradient, equals, let's do minus 6 minus 0 over 0 minus 2 equals minus 6 over minus 2 equals 3. Okay. Let's also find the midpoint of BC. And that equals, let's add them together. So it's 2 plus, so it's 2 plus 0 over 2, which is 1. And it's minus 6 plus 0 over 3 over 2, which is minus 3. So the midpoint is 1 minus 3. And that's there. So the CA, let's call that D. So DA equals the opposite of that, so y equals minus a third, as it's the negative reciprocal, x plus c. And c is going to be about, I don't know, 2 minus 2, I think. And then we'll put those in, so we get minus 3 equals minus 1/3 1 plus c. Let's times everything by 3, so we get minus 3 is minus 9 equals minus 1 plus c. What? That's not right. Okay. And that's add 1 onto both sides, so minus 8 equals, that doesn't make sense, c. So that's y equal, I don't think that's right. So we know that's minus 3, yeah, that's 1, so that's definitely there. But you see, the reason I don't think that looks right is because it's there, hang on, so that's minus 3, that's 1, 3, oh, 3c, there you go. So that's minus 8 over 3. I apologise about that. So that means that y equals minus a third x minus 8 over 3, which is exactly the right answer. If you find yourself thinking this isn't right, sometimes it is and sometimes it really isn't. And getting those Prove algebraically that the difference between two squares of any two consecutive odd numbers is an even number. Okay, two consecutive odd numbers, so let's call them n plus 2n plus 1, 2n plus 3. And the difference between the squares is an even number, so let's say 2n plus 3 squared minus 2n plus 1 squared, and that's 4n squared plus 3 times that plus 12n plus 9 minus 4n squared plus 4n plus 1. Yeah, that makes sense. So that is going to equal, get rid of those, 12n, so that's 8n plus 8. And then if we want to be technical about it, it's this. So we've got a 2 on the outside, so always even. Okay, that was fun.